to use the Pythagorean theorem. Each side of a rhombus is 14 inches long. 14, 14, 14, 14. Two sides form a 60-degree angle. Let's pretend it's this one because it looks like it is. Not find the area yet. That's a little ahead of the game. Let's just find the diagonals. So what we need to do is draw both of them. So what's special about this is, first of all, if this is 60, the diagonals cut that in half. So that's 30 and 30. But what also you should know about a rhombus, or rhombi if you will, the plural, 60 plus what equals 180. These are supplementary, the whole big angles. 120. So this is 60 and 60. And the reason I also know that is because this is a right angle because the diagonals in a rhombus are perpendicular to each other. All right, they're also bisectors, so of each other. So this side's equal to this, whereas this one is equal to that one. But the diagonals themselves are not completely congruent. Okay, now this is why this works. Let's take this triangle off to the side here. This right triangle, which I'll try to draw it like it is. If this is 14, and that's the right angle, and this is 60 and this is 30, well then this is the 2x side because it's opposite the right angle. This is the x side. This is the x root 3 side. So if 2x equals 14, then this must be 7, and this must be 7 root 3. So 7 root 3 here. Oops. 7 root 3 also here. 7 here. 7 here. The diagonals are 14 and 14 root 3. That's how you add 7 root 3 plus 7 root 3. You just add the 7s. Having fun? All right, so we're at 12 minutes, I could see. Just had those. Here we go. Let's go to this one. I don't think you have this on any page. These are questions. I pulled these for the notes, and then this is the sheet that I pulled them from, and I got some other nice little nifty questions here. So what's nasty and disastrous about this one? Side opposite 60 is x. Oh boy. And I'm crossing off D just because I don't want you to get confused either. Side opposite 60, this is the trouble. This is supposed to be the x root 3 side, and they give me a number there. So that's the given. So what I need to do is find this side, all right? Because this is double that, all right? So how do I find what this length would be? Well, it's all relative to knowing this. This is supposed to be the x root 3 side, but they tell me it's 25. So what I have to do is set that equal to 25 and then solve. The only way you can do that is by division. So what I end up is, okay, wait, I want to rationalize now. So you have to divide by root 3. This is the part where you can have a trouble. These are the questions that separate the men from the boys, women from the girls, so to speak. So, you know, this is where you got to pay attention here and hopefully grasp it. This comes out of my head. This is equal to 1, something over itself. So when I multiply something by a form of 1, things don't change. Then some things you should know about, you know, teaching those little buggers when you become a teacher. When you multiply fractions, you just multiply across. And you multiply across. How you multiply a root with a root? You just multiply the numbers inside. And then the square root of 9, everyone can tell me, is 3, I hope. That is why you did this. This is called rationalizing the denominator. Sometimes you get a nicer looking answer than this, like the one we had a couple ago. Where was that one with the radicals? I don't know where we're at. This one. So when you rationalize the denominator, 28 divided by 2 just became 14 root 2. That's nicer looking, you know, than 28 over root 2. This is why you do it most cases. Sometimes you don't get something so pretty. So what? You still have to do it. So x equals this number. That means this side equals that because this is the x side. All right? So that is it, what it is in relationship to this side. So you got to figure that out. You got to figure out that this is what happens. Then, what is this side? Double that one. So I'm just going to do something real nifty. When you take 2 times 25 root 3 over 3, 2 over 1 by the way, and then you should be teaching those little buggers this. you multiply the numerators. And then, yeah, you multiply the denominators, but that's just 1 times 3. So those are the side measures based off of this given piece of information. That's what you got to do when they come for you. All right. Let's take a look at a few more here, see if they're worthy of our, yeah, here's another one. Wah, wah, wah. Okay, the reason we're sad about that is because this is the x root 3 side again. This is the x side, and then this is, you know, they're just telling you find this one, but this is the 2x side in the 30, 60, 90 relationship. So unfortunately, you do have to find this side to get this side, because this is double that. All right, and the only way you could do that is based off of what I just showed you in the last one. You set x root 3 equal to 14. You divide. You may end up patterning this out when you understand what you have to do to rationalize. This is 14 root 3 all over 3, and these don't reduce. But that's this side. So this is double that. Now I'm going to erase that and then write 28, because when you double, you just double the numerator, because that's how you multiply fractions. That's what that diagonal length is then. Alright? Alright, again, you can always watch and rewatch. Hey, what kind of triangle is this? It's a square, right? But this is an isosceles 45, 45, 90. You could go ahead and do the Pythagorean theorem. This squared equals this squared plus this squared and solve. Or you could understand that this is the x, this is the x side, this is the x root 2 side. So basically this is one where you plug in root 2 right here. Because this side is whatever this side is times the square root of 2. I know you have a root 2 there, but what's root 2 times root 2? No time. Root 4. What's the square root of 4? No time. It's 2. So z equals 2, and that's the length of that diagonal. Is this another annoying one? Not so much, because this is the x side. Hey, they finally lined up. Whatever this side is, this is the x root 3 side. So we'll say when we get this done, that's what this represents. And this is the 2x side. So if this side is double whatever side this is supposed to be, I think you could figure out that this has to be 15 then. Or set those equal and solve for x. And you will get x equals 15. And that's what we mean. That's what that side's supposed to be. Again, all 30, 60, 90s have this relationship. So then what does this become? Come on, it's 15 root 3. Whatever this side is, times the square root of 3. That's what this side is. So that's how you have to approach it. All right? All right. And then this is another 45, 45, 90, please. You could just do the Pythagorean theorem. Or understand this is the x root 2 side. This is the x and x. There's that s letter that I don't like. X root 2 equals 6 then is what you do. You could have done the Pythagorean theorem too if you don't like what I'm doing here. You have that option with 45, 45, 90s. Not with 30, 60, 90s. So you must understand that you might want to take a look at those last couple of things I did there on those. See if I have any other special questions. Oh yeah, connector. I love these. Last but not least, and hopefully we'll be done in at the 20-minute mark. So I'm going to fly through this. First of all, 45, 45. So x is 5 because it's an isosceles. So that makes y 5 times the square root of 2. X root 2 for a 45, 45, 90. Not explaining that. Okay, because now what we do is use that as a bridge to connect it to the 30, 60, 90 and concentrate on this now. So 30, 60, 90. Side opposite the 30 is supposed to be the x side. Oh, brother. The side opposite the 60 is supposed to be the x root 3 side. Side opposite the 90 is supposed to be the 2x side, and that's what I'm going to do for those letters. So that means x root 3 we set equal to 5, so we can find out what x is. What is that in relation to this situation? You're going to get that nasty fraction. That rationalizing that doesn't do a whole lot, doesn't make it look very nice. Root 3 times root 3 is root 9. All right? Square root of 9 is 3. So z is 5 root 3 over 3. That's what z is. Then, I didn't make the 20 mark. It's already 20 minutes and 15 seconds. Sorry. Then this side is double that. So W is 2 times 5, 10 root 3 over 3. Again, that fraction work. 2 times 5 root 3 over 3. It's 2 over 1. And you multiply the numerators. And you can only multiply the numbers that are on the outside of the radical together. So that's how I get that 10 root 3 over 3. Okay, it's a little connector question you will see on your quiz. So I hope you watch this, and it's imperative.